Let's look at episode 13 of Prime Puzzles. Getting to it. Set 1. In a live hypnosis show, a famous hypnotist called one participant named Donald on stage. During the show, the hypnotist displayed a number on an electronic screen for 1 second. He then gave Donald instructions to use the digits of the number that were displayed on the screen to create a new number which used the same digits as the number displayed on the screen and say the new number aloud. The hypnotist claimed that Donald could arrive at the new number in just 3 seconds' time after conforming to all the instructions given to him. So in terms of global information that is applicable to all the setups, all the potential cases, there is very little information apart from the fact that you'll be given some number with some digits and you have to create a new number. That is all the instruction that you have. And additionally, that number can be created in 3 seconds time. Okay. First question. The hypnotist displayed a 7-digit number with all digits different on the screen and said, Donald, rearrange the digits of the number to create a number such that at least 4 digits of the number are in the same position as the number on the screen. Say the number you have created aloud. How many different numbers could Donald have said if he followed the instructions of the hypnotist? So let's start working with a 7-digit number with all digits different. 1, 2, 3, 4, 5, 6, 7. And now he says at least 4 digits are in the same position. At least 4 digits. So if at least 4 digits, same position, if you have 4 digits, varying position, you will have 3. But it says at least 4. It's not like you have to have exactly 4 digits in the same position. You can also potentially have 5 digits in the same position and 2 digits will change places. And then you also have, can you have 6 digits in the same position and varying digit 1 and 7 digits in the same position and digits not in their original position 0, basically the same number repeated. Let's go through each of these cases and move from down to. Can I have all 7 digits in the original place and no digit changing? That is not possible because the instruction given to us is create a new number. If you have all 7 digits in the original place, then you are not creating a new number. It is the same number. So this case is not possible. With 6 digits in the same spot and 1 changing its spot. Let's say the 6 digit in the same spot are the first 6. 1, 2, 3, 4, 5, 6. Can you see the only spot left for 7 to come is in the last spot? And thereby, it is not just 6 digits are in the same place. It is all 7 are in the same place. And this is impossible. This is not happening. This will definitely not work. So we cannot possibly have 6 digits in the same place and 1 varying, because if 6 digits are in place, the 7th digit automatically is in place. So this case is also out. Let's look at case of 5 digits are in the same place and 2 digits are switching places. If 2 digits are switching places, let's say the first 5 digits, they are in the same place. 1, 2, 3, 4, 5. If 2 digits are switching places, there is only one possible case. 7 and 6. You get 7, 6 switching places in the last 2 spots. 1, 2, 3, 4, 5 is same. Now 1, 2, 3, 4, 5 is not a unique case. Basically, out of these 7 digits, you can select which 5 digits will remain in the same place in 7C5 ways. And for each of those 7C5 ways, can you see, you will only have one way in which the remaining 2 digits can change. So you get these many cases. Okay. Now let's look at same and varying. 4 same and 3 varying. I'm saying let these 4 be in the same place. I have 1, 2, 3, 4. Now I have to fill up 5, 6, 7 in new spots such that neither 5 is at the same spot, neither 6 is at the same spot, neither 7 is at the same spot. So can I have 7, 6, 5? No, 6 is in the same spot. This doesn't work. Can I have 7, 5, 6? Yes. This is an acceptable case. In fact, for 5, 6, 7, can you go ahead and list out all possible variations? 6, 5, 7, 6, 7, 5. 7, 6, 5, 7, 5, 6. These are all the possible combinations. This was the original one, so therefore cannot be counted. The second case cannot be counted because 5 is in the right spot. This is not counted. 6, 5, 7. 7 is in the original spot, so this cannot be counted. 6, 7, 5. Yes, this case is possible because 6 is not in the right spot. 7 is not in the right spot. 5 is not in the right spot. 7, 6, 5. 6 is in the right spot, so this case cannot be counted. And 7, 5, 6. This case can indeed be counted. Can you see out of the 3 digits, out of the 3 digits that are changing their place, for every group of 3 digits, you get 2 subsequent cases. You get 2 subsequent cases where they can be rearranged. So first you select the 4 that are not changing places, and then the remaining 3 digits that are there, they can be rearranged in 2 ways. And this altogether should give you the total number of cases that you want. 7C4 is 35, 35 into 2 is 70. 7C5 is 7C2 is 21. So 70 plus 21. The answer to the first question will be 91. Now I've gone ahead and written this all down. We could have worked with the idea of derangement. I think it is double R. So derangement. I'm not entirely sure of the spelling. We could have worked with the idea of derangement, which would have been 7C4 into D3 and 7C5 into D2. But I'm not sure how many people are familiar with the idea of derangement, and therefore I've gone ahead and listed out all potential cases. In case you're interested, please go ahead and read up about derangement. Your life, maybe you learn a new concept, which is not entirely necessary for CAT, but if you know it, it gives you more strength. Okay. This takes care of the first question. This takes care of the first question. Moving on to the second one now. It says, the hypnotist displayed a 7-digit number with all digits different on a screen and said, Donald, rearrange the digits of the number to create a number. The position of each digit in the number can vary from its position in the number on the screen by at most 1 place. Okay. Donald, say the number you have created aloud. How many different numbers Donald could have said aloud if he followed the instructions of the hypnotist? Okay. Let's say we had this. The number was 1, 2, 3, 4, 5, 6, 7. Fulfills the criteria, all digits different. Now, let's say I wanted to switch 1 to 2, and then I try to switch. Now 2 has 2 options. 2 cannot come in its original place. 2 can come either here or here, can come to the first spot or the second spot. So I'm just making a case with 2 coming to this spot and just showing you how this is impossible. If 2 comes to the third spot, which digit will now come to the first spot? Which digit will now come to the first spot? If 3 comes, it is a problem. If 4 comes, it is a problem. If 5 comes, it is a problem. If 6 comes, it is a problem. If 7 comes, it is a problem. Because the condition given was each digit in the number can vary from its position on the number on the screen by at most 1 place. So this movement of 2 to spot 3 is impossible. That is not happening. Where can 2 go? Only 1 spot. Can you effectively see what has happened is a pair of 1, 2 has swapped places with each other. A pair of digits have swapped places with each other. So if I have to create a new number, I can either have 1 pair swapping places, or I can have 2 pairs swapping places, or I can have 3 pairs swapping cases. This is the exhaustive list of possibilities. I cannot have 4 pairs because there are only 7 digits available. So I'm saying, let me just identify pairs. So if I'm having only 1 pair swapping places, that pair could be 1, 2. That pair could be 1, 2, or 2, 3, or 3, 4, or 4, 5, or 5, 6, or 6, 7. How many cases do I get? I get 6 cases. If only one pair was swapping places with each other. If only one pair was swapping places with each other, I will have 6 cases created. Okay. If we have, where am I going? If we have two pairs swapping places with each other, and I'm starting off with, let's say the first pair was 1, 2. The second pair can now be 3, 4, or 4, 5, or 5, 6, or 6, 7. So you get 4 cases here. But remember, we had started by assuming 1, 2 is definitely that first pair of digits that are swapping places. That is not necessarily true. It is not imperative that 1 and 2 will necessarily swap places with each other. We could also have the first pair as 2, 3. And then the second pair could be 4, 5, or 5, 6, or 6, 7, which gives me 3 more cases. Let me now look at, let's say the first pair we have identified is 3, 4. So the second pair could be 5, 6, or 6, 7. At this time, somebody might say, we can also have this pair 1, 2. But can you see the pair of the grouping of 1, 2 and 3, 4 was already counted when we were counting pairs with 1, 2, no? You don't have to count the pairs that are getting created on the left-hand side. You only have to count the pairs that are creating on the right-hand side. That will give you your exhaustive cases. Because we are moving in such a structured fashion, no case is going to be missed out. So when we have 3, 4 as our original pair, and we are looking for a second pair, it can either be 5, 6, or 6, 7. So we get 2 more cases. Cool. And finally, by now you should also have seen a pattern emerging. If we take 4, 5 as the initial pair, the final pair can only be 6, 7. So you get 1 more case, or a grand total of 10 cases from here. You get a grand total of 10 cases from here. This is all the counting for 2 pairs that are swapping places with each other. Let us now look at 3 pairs. If we are looking at 3 pairs, I will just go ahead 1, 2, 3, 4, and 5, 6. We are excluding 7. Or we can have 1, 2, and 3, 4, and 6, 7, and we are excluding 5. Or we can have 1, 2, exclude 3, 4, 5, and 6, 7. Or we can have another case of exclude 1, 2, 3, 4, 5, and 6, 7. When we're dealing with 3 pairs, because there are only 7 digits, it is very easy to see. We are either excluding 1, or 3, or 5, or 7, and whatever other pairs are possible, we will have those 3 pairs. So I get 4 cases from here. In total, I get 6 plus 10 plus 4, or I get a total of 20 cases, or option B for this question. Moving on. The third question, the hypnotist displayed an 8-digit number with only 1 digit repeated exactly once and said, Donald, rearrange the digits of the number to create a number such that at most 2 digits of the number you have created out of the 8 can be out of place. Say the number you have created aloud. Okay. So let's say the 8-digit number was 1, 2, 3, 4, 5, 6, 7, 1. 1 and 1 are the same digit because 1 digit was repeated exactly once. Now you have to create a new number, and it says at most 2 digits you have created can be out of place. See, if at most 2 digits have to be out of place, can you have a case of 0 digits out of place? No, that is impossible because we were told create a new number. Can you have a case of exactly 1 digit out of place? If you remember from this question, you cannot have exactly 1 digit out of place. You need at least 2 digits out of place. So when this question says at most 2 digits out of place, effectively the question is telling you exactly 2 digits have to change places. Exactly 2 digits have to change places. Now, the what do I say? The intent here, or the tendency here, would be to, let's use 8C2 out of these 8 digits. Let me just select 2 and I will swap places among them. But see, 8C2 technically here is incorrect because NCR is defined as selecting R objects out of N distinct objects. 1 and 1 are not distinct. So you cannot really apply NCR here technically, unless you think of it this way. This is 1A and this is 1B. Now they have become distinct, and now you can apply 8C2 thought process wise. It is not technically incorrect, it is appropriate. But when we have identified the two digits, that we have selected two digits, those are the two digits that we intend to swap places with each other. Two digits are out of place, so they are swapping places with each other. Within these 8C2 cases, will there also be a case when these two digits are selected? And when you switch their spots, the number will look like this. Can you see? This is no different than the original number, because this A and B, this distinction we have introduced, it wasn't really present in the number. So out of the 8C2, apart from this, no other case is unacceptable. Every other case is fine. Only this case is the case that we have to eliminate. So our answer to the third question has to be 8C2 minus 1, which is equal to 28 minus 1, which gives me the final result as 27. Okay. Now the last question. The hypnotist displayed the 8-digit number 1, 2, 3, 1, 4, 3, 5, 6 on the screen. 1, 2, 3, 1, 4, 3, 5, 6 on the screen and said, Donald, rearrange the digits of the number to create a number such that at most 4 digits in the number on the screen can be allowed to vary from their positions by up to 1 position in the number. So fun. When we could vary digits by up to 1 position, we had to work with pair of digits swapping places. And now it says at most 4 digits are allowed to be varying from their position. Effectively, they're saying either 1 pair is swapping place or 2 pairs are swapping places. Simply count those cases in which either 1 pair is swapping places or 2 pairs is swapping places. Some people might also get a little worried. Ooh, this has 1 and 1 repeated. This has 3 and 3 repeated. Will that in any way impact our counting? Not really. Because can you see 3 and 3 are not next to each other? Not next to each other. Similarly, 1 and 1 are not next to each other. Only when 1 and 1 or 3 were next to each other, because we are swapping only numbers that are right neighbors of each other, only then would this matter. Right now, it wouldn't matter. I can happily switch places without really concerning myself with if there are digits repeated or not repeated, because they're not close to each other. Which is why, can you see in this case, they did not go ahead and specify the number to be used. They simply said 1 digit is repeated. You could place that repeated digit anywhere. Here they have specified the number, because in the absence of this, if the number was 1, 1, 2, 3, 4, 3, 5, 6, if the ones had been together, then the count will be different. Now that you have this number, the count will be different. The reason for them specifying the number in the question holds as in, there is a reason. There is a reason. It's not willy-nilly that they have decided, okay, let me give them a number to make their life smoother. Okay, so we've got this number. So only when 1 pair is swapping, I can go 1, 1, 2, 2, 3, 3, 1, 1, 4, 4, 3, 3, 5, and 5, 6. So 1, 2, 3, 4, 5, 6, 7. Only 1 pair is swapping places with each other. I will get 7 cases. Now, when 2 pairs are swapping places with each other, I can have 1, 2 followed by 3, 1, 1, 4, 4, 3, 3, 5, and 5, 6. So when there are 2 pairs involved, I have 5 cases initially. Next setup, if I have to count, I don't know how many of us have caught on, but all we are doing now is 6C2. Let's see if you can catch on. Basically, I have 2, 3 here, and then I have 1, 4, or 4, 3, or 3, 5, or 5, 6. So 4 more cases. If the original pair was 3, 1, I can have 4, 3, or 3, 5, or 5, 6, or 3 more cases. By now, hopefully, pattern has emerged for you to make your life easier. If 1, 4 is taken as the original pair, then you have 3, 5, and 5, 6. So 2 more cases. And finally, if you have 4, 3 as the original case, you have 5, 6 as the second pair. Altogether, you get 15 cases from here. And surprise, surprise, 6 into 5 into 2 is also giving you 15. In fact, you can go back and see here, when you had two pairs, after you had identified this, the first pair, you're left with 5 digits. You're doing 5C2. 5C2 is 10. Here you have 6C2, which is 15. Anyway, if you can count it, I don't want to get into heavy PNC derivation of how that is happening. All I want you to see is we can count it slowly and we can still reach our result. 7 cases and 15 cases. Altogether, we get 22 cases. Answer to the question is option A, 22. This is again one of those sorts of questions which claims to be a DILR question, but is using heavy concepts from quant, and patience is required. It's not like you need to do a lot of mathematical processing and lots of math. You need to count things very appropriately. Okay, let's move on to the second set. Chandrakanta Devi has 8 grandchildren named Ishu, Radhika, Deepa, Rinku, Ira, Vicky, Abhishek, and Achal. She had 36 gold coins with her. On her 75th birthday, she gifted the coins among her grandchildren such that the eldest grandchild got 8 coins, the second eldest grandchild got 7 coins, and so on. And the youngest grandchild got 1 coin. After getting the coins, the 8 grandchildren played a game in which each of them got a different rank. Okay. The winner in the game got 8 coins from the eldest grandchild. The first runner-up got the 7 coins from the second eldest grandchild, and so on. So basically, these children engaged in gambling. You got some coins, and then you played a game, and then you redistributed the coins that you had with yourself. Okay. For every grandchild, gain in the game is equal to the number of coins with him or her after the game is over, minus the number of coins gifted to him or her by the grandmother. If the number of coins after the game is more than the number of coins gifted by the grandmother. Cool. Loss in the game is equal to number of coins gifted to him or her by the grandmother and the number of coins with him or her after the game is over. If the number of coins after the game is less, okay, these are basic definitions of gain in the game and loss in the game. This is nothing. This is profit and loss description. SP minus CP and CP minus SP. Okay, following points are known. So we get to instructions now. I know there are 3 parameters that I have to take care of. First is name. Let me just make a table. First is name. Second is initial number of coins. And the third is final number of coins. So I have 1, 2, 3, 4, 5, 6, 7, and 8. Okay. This is the name, initial number of coins, and the final number of coins. Let's get to individual instructions. What are they saying? Vicky is not the eldest and he did not win the game. Okay. So I have somebody by the name of Vicky. He is not 8 in the initial grouping and he is not 8 in the final grouping. Because he's not the eldest, he would not have received 8 coins initially. And because he's not the eldest, he would not have received 8 coins. He did not win the game. He would not have received 8 at the end. The number of coins gifted to Deepa by her grandmother was a composite number. Okay. So Deepa initially would have received either 4 coins or 6 coins or 8 coins. These are the 3 possibilities. The number of coins she had after the game was a prime number. Okay. So after the game, she either had 2 coins or 3 coins or 5 coins or 7 coins. Okay. The grandmother gifted coins equal to the number of letters in the name of only one grandchild. The grandmother gifted coins equal to the name of letters in the name of only one grandchild. Okay. At this point, this seems like an important instruction, but at this time, the only thing I can infer out of it is Deepa is not that child. Deepa, if she had received coins equal to the number of letters in her name, she would have gotten 5 coins. But the only possibilities for Deepa are 4, 6, and 8. So Deepa is not that child. Okay. The number of coins gifted by grandmother to Rinku was more than exactly 5 other grandchildren. Okay, so Rinku got 6 coins initially. If Rinku got 6 coins initially, Deepa cannot potentially have gotten 6 initially. This is also identified. And we also know Rinku is not that child. According to point 3, Rinku is not that child. If Rinku had received coins equal to the number of letters in her name, Rinku would have received 5 coins, but she's getting 6. Okay, back to point 4. She was the only one who did not have either gain or loss in the game. Okay, so Rinku finally had 6 coins. Okay. Ira lost 4 coins in the game. Okay. Ira lost 4 coins in the game, which was more than the loss suffered by any other grandchild. Further, Ira did not get 7 coins from her grandmother. Can you see this wonderful thing? If Ira is losing 4 coins, Ira needs to have more than 4 coins initially. Ira needs to have more than 4 coins initially, because the worst case scenario for you in the final state is you having 1 coin. If you've lost 4 coins and you end up with 1 coin, you at least had 5 initially. So the possibilities for Ira would be 5 coins initially, but not 6, because Rinku already has 6. Additionally, we know that Ira did not get 7 coins from a grandmother, so 7 is also not possible. Ira can only have either 5 or 8 coins initially, and because she is losing 4 coins in the game, she will finally have either 1 or 4 coins. Also, along with this, she is the max loser. She is the max loser. Ira lost 4 coins in the game, which was more than the loss suffered by any other grandchild. Nobody has suffered a loss as great as Ira. Okay. Achal and Abhishek. Okay. One more thing. Ira, for point 3 now. Ira has either 5 or 8 coins initially. So Ira is also definitely not that child. Ira is also definitely not that child who has gotten coins equal to the number of letters in the name. Next is Achal and Abhishek had consecutive number of coins both before and after the game, such that Achal got fewer coins than Abhishek both before and after the game. Okay. I have Achal and I have Abhishek. And I know if Achal had n here, Achal can have, Abhishek can have n plus 1. If she had k here, Abhishek can have k plus 1. Okay. But, okay, fun thing. Can Achal be that kid being referenced in 3? Can Achal receive 7 coins? No, because if Achal received 7 coins, Abhishek would get 8. And point 3 says the grandmother gifted coins equal to the number of letters in the name of only one grandchild. If Achal received 7 coins, Abhishek, who has 8 letters, would also receive 8 coins, and it would no longer be true for only one grandchild. So at this time, I can rule out Achal also from this list and Abhishek also from this list. Achal and Abhishek are also not people who have gotten coins equal to the number of letters in their name. Okay. Next is 7. Radhika gained more coins in the game than any other grandchild. Okay. Radhika gained more coins in the game than any other grandchild. So she's the max winner. She's the max winner. Okay. At this time, I expect you to make a judgment call. Can Radhika be the child being referenced in point 3? If Radhika got coins equal to the number of letters in her name, Radhika would have ended up with 7 coins. Now, finally, max Radhika can go up to is 8 coins. Max Radhika can go up to is 8 coins. If Radhika is only going up till 8 coins, so her gain is only 1. then she will definitely not be the max winner. If you're only gaining one coin, you're definitely not the max winner when you already have a loser like Ira in play. When you already have a loser like Ira in play who has moved 4 places down, then Radhika will not be the max winner if she's only gaining 1 coin. So at this time, I will rule out Radhika from the list as well. So it is not Deepa, it is not Enko, it is not Ira, it is not Achal, it is not Abhishek, it is not Radhika. Next is Ishu did not suffer a loss in the game. Okay. So Ishu did not suffer a loss in the game. Can I say here Ishu's number has to go up? From here to here, number has to go up. This much I know. Last is Vicky did not get 5 coins from the grandmother. Okay, so this is interesting. If Vicky did not get 5 coins from the grandmother, Vicky is also not that kid. The one being referenced in point 3, the one who has got number of coins equal to the letters in the name. Deepa is not it, Rinku is not it, Ira is not it, Achal is not it, Abhishek is not it, Radhika is not it, Vicky is not it. The only person left would be Ishu. So Ishu initially had 4. And because her number finally has to go up, she will either have 5 coins eventually, or 7 coins eventually, or 8 coins eventually. 5 coins eventually, or 8 coins eventually. Okay. Now see, Radhika, I'm saying cannot be 8. Radhika cannot be 8. Abhishek cannot be 8. Radhika cannot be 8 because she's the max winner. Radhika cannot be 8. Abhishek cannot be 8. Achal cannot be 8. Okay, so Achal, Abhishek, Radhika, and Vicky cannot be 8 because it is given. Achal cannot be 8 because Abhishek would need 9 coins then. Abhishek cannot be 8 because then the number of coins in his coins that he has received would be equal to the number of letters that he has. And Radhika cannot be 8 because she's the max winner. Okay, so this is turning out to be interesting. How do I fix it? Do I have 1 somewhere? 1. 8 I can fix somewhere. 7. Can Achal be 7? No. Can Abhishek be 7? If Abhishek is 7, then Achal will be 6. That is not possible because Rinku cannot be 6. Oh, 7 is the number. Achal cannot be 7 because if Achal is 7, Abhishek will be 8, and both of them will have equal number of coins as the letters in the name. So they cannot be 7. Radhika also cannot be 7 because then her being the biggest winner is not possible. So the only place that you can potentially, the only person who can potentially have 7 coins initially is Vicky. The only person who can potentially have 7 coins initially is Vicky. Additionally, if Vicky is here, Vicky is not having 8 coins finally. Vicky is also not having 7 coins finally because the only person who maintained his number of coins from the initial phase to the end phase was Rinku. Vicky cannot have 7 coins. Vicky cannot have 6 coins. Vicky can have 5 coins. Yes, it is possible for Vicky to have 5 coins. Vicky can have 4 coins. Yes, it is possible. Vicky cannot have 3 coins either. Remember, the max loser was Ira, and she has lost 4 coins. If Vicky went to 3, Ira and Vicky would become equal max losers. That is not possible. Okay, so that is also taken care of. Vicky goes from 7 to either 4 or 5. Cool. Now, okay, 4. Oh, Deepa is 4. As in Deepa cannot be 4. This is identified. If Ishu is 4, Deepa cannot be 4. Deepa is 8. If Deepa is 8, Ira is 5. This is also identified because cases. And then Ira also has finally got 1 coin. This is also identified. And for Deepa, look at this. Deepa can lose. Deepa has to lose less than 4 coins because the maximum loser is Ira. So Deepa cannot possibly have 4 or 3 coins initially. 2 or 3 coins initially. Finally, she will either have 5 coins or 7 coins. 5 or 7. Okay. Let me write it 1. I'm unable to make the link there. Okay. So these cases I have now. These cases I have now. Okay. So possibilities I have to identify. Let's see if Vicky had 5. Okay, so here I have Achal and Abhishek are supposed to be consecutive numbers. So either I will have 1, 2, and 3, or I will have 1, 2, and 3. These are the only possibilities left. So I'll mention this case in circles. I'll mention this case in boxes. These two possibilities I have, which seems fine. Okay. Now let's see. Radhika needs to go up till either 8 or 7. If she goes up till 6, is it fine? Maybe even that will work out. If it is 1 and 6, 5 max can go. Let's see which possibilities can Achal and Abhishek. See, I have listed out cases for their initial number of coins. Let's see what possibilities are available for Achal and Abhishek finally. K and K plus 1. They cannot be same. So 1, 2 can be possible if they are 2, 3 initially. It can be, sorry, it cannot be 1, 2 because 1 is already with Rinku. 2, 3, can they have? Yes, they can have 2, 3. But remember, 2, 3 is possible only when 1, 2 you have initially. Can they have 3, 4? Potentially. Can they have 4, 5? Yes, potentially. Can they have 5, 6? No, because Rinku is 6. Can they have 6, 7? No, because Rinku has 6. Can they be 7 and 8? Potentially. Sorry. If they become 7 and 8, they will become heavy players. They will become heavy players because Radhika has to be okay. If they become 7 and 8, then Radhika, what will she be? What Radhika has very little 7 is used up, 8 is used up, 6 is used up. The heaviest she can go is 5. And if she goes 5, she will gain 4 coins. And the smallest gain here for Abhishek will be for 5 coins from the second case, 2, 3, 1 to 7, 8. Abhishek has already gained 5 coins. So Radhika cannot win in that case. So I can rule out 7, 8 as a possibility. Sorry. 7, 8 as a possibility I can rule out. So I have potentially these cases. So with 1, 2, 3, I can have 2, 3 here. Then with everything else works. Okay. Now see, in my head, what I'm thinking is Radhika, regardless of being 3 or 1 initially, Radhika has to be a large number. If Radhika is 5, let's say Radhika was 5. I'm going to check cases now. So let's say Radhika was 5. In this case, 3, 4, 5. So 1, 2, 3, and 3, 4, 5. Radhika has only joined 2 coins, has only gained 2 coins. If she has only gained 2 coins, or 3 to 5, no, 2, 3, 1, and 3, 4, 5. Radhika has gained 4 coins. But as soon as Radhika becomes 5, Vicky becomes 4, and Deepa becomes 7. Also, if 5 is used up, Ishu becomes 8. If Ishu becomes 8, Ishu has also gained 4. Radhika has also gained 4. So this is unacceptable. Similarly, from 3 to 5 also case is unacceptable. So I can happily rule out the 3, 4, 5 case, because regardless of what initial case you take, Radhika is not gaining too much. In the 4, 5 case, let's say Radhika becomes, Radhika becomes 6 is used up. Radhika becomes 7. If Radhika becomes 7, then this case is gone. Then this case is gone. 5 is used up. 7 is used up. Okay, so 8 comes here. No. The problem is now Deepa is also 5. Abhishek is also 5. Deepa is also 5 and Abhishek is also 5. We cannot have that. So Radhika being 7 is not acceptable. Let's see if Radhika was 8. If Radhika was 8, so this 5 is gone, this 5 is gone. 5, 7, and 8 are all gone. So Ishu will no longer have any number available to her. So this is also unacceptable. Can you see Achal and Abhishek eventually having 4 and 5 leads to no cases possible. Radhika has to go to a higher number, and there are no cases possible for Radhika to go to, which at this time means you cannot possibly have 4 or 5 as final number of coins for Achal as well. So for Achal, the final number of coins have to be 2 and 3. If they have to be 2 and 3, you cannot have the 2, 3, 1 case happening at all. You cannot have the 2, 3, 1 case happening at all. So 1, 2, 3, the initial number of coins are uniquely determined. This is fine. Now let's go to 2, 3 is identified here. Okay. Now let's see Radhika. Radhika, can you have 5? If Radhika had 5. If Radhika had 5 here, then what would happen? This 5 gone, this 5 gone, this 5 gone, this 7 gone. Radhika is gaining 2. Ishu is gaining 4. So this case is unacceptable. Radhika cannot have 6 because Rinku has 6. Radhika having 7. If Radhika has 7, Ishu now has 4. Radhika also has, Ishu now has a gain of 4. Radhika also has a gain of 4. So this is also not acceptable. The only case where this will work, is if Radhika ends up with 8. If Radhika ends up with 8, this is gone. And now see, because 5, 7, Ishu has one number out of 5 and 7, and Deepa has the other number out of 5 and 7. Can I say 5 and 7 coins finally will be distributed between Deepa and Ishu only? So for Vicky, we definitely know the final number of coins is going to be 4. The final number of coins is going to be 4. And there is no clear demarcation why Deepa should have 5 or 7. There is no clear demarcation why Ishu should have 5 or 7. This is where we stop. First question, who is the youngest grandchild of Chandrakanta Devi? Is Achal. Who got 5 coins at the end of the game? We don't know. It could either be Deepa or it could be Ishu. So cannot be determined. Finally, next question. If Deepa loses 1 coin in the game, then how many grandchildren gained exactly 1 coin from the game? So Deepa loses exactly 1 coin. So Deepa has 8 and 7. So Ishu will have 4 and 5. So Ishu is that kid who gained 1 coin. Radhika gained 5. Abhishek gained 1. Achal gained 1. Ira lost 4. Rinku gained 0. Deepa lost some. Vicky lost some. So when this question is asking me how many grandchildren gained exactly 1 coins from the game, it has to be 3 grandchildren. Last is how many coins does Vicky lose in the game? 4. So again 3, because from 7 he has gone down to 4. At this time, you also need to appreciate, as in when I had created this entire table and recorded everything, I was not that confident of maybe I have missed out on something, because 5 and 7, ideally I would have wanted unique values here, but I did not get that. But when I look at question 3 and 4, the confidence surges, because what these questions are telling me is, for Deepa, you will not get a unique case. Eventually, for Deepa, you will not get a unique case. And that was true. I was getting 2 possibilities for Deepa. And question 4 tells me for Vicky, you will get a unique case. I do have a unique case for Vicky. So basically, my fears about me having missed out on some important information goes away when I look at question 3 and 4. Hopefully you learned something from my struggles to solve the sets today. That will be all. Okay, bye people.